All right, let's begin. So thank you everyone for joining us this morning for the GreyTech webinar, and we'll be having a look at working with 3D sketches in Inventor 2022. Just a brief background about me. My name is Daniel Payton. I'm an application engineer in the manufacturing team at GreyTech. If you are looking for my details to contact me, my email address and my LinkedIn profile are added in over there. And this is included in the handouts. So if you are looking for this presentation, it is included in the handouts section of the GoToWebinar. A bit about my background. Prior to working at GreyTech, I was in the industry for over 9 years. And during that time, I worked as a design engineer, both in the automotive industry, where I was designing buses, and I worked in the entrance control industry prior to that, where we were designing a range of products. And during that time, I've worked with a range of materials like tubular steels, sheet metals, glass, and plastics, and fiberglass, and those kinds of things. So I do have a good understanding of manufacturing techniques and different materials. So that's just a little bit about me. Some key facts about GreyTech. So GreyTech is over 30 years old. They are headquartered in France and currently operate in over 11 countries worldwide through over 48 offices. We are a healthy, profitable, and growing company, and we continue to grow year on year. And as we grow, we tend to acquire companies as well to increase our product offerings and to increase what we can supply to our customers and assist our customers with. We have over 550 staff members. 100 of those staff members are located in an R&D center where they produce class-leading BIM solutions. So GreyTech are not only a reseller of Autodesk software, but they also create and resell their own software, as well as creating things like Power Packs, which add additional functionality to existing Autodesk software. We also have 200 industry consultants that are focused on customer delivery and outcomes. We also have local project and product management. And we believe that the customer should always be put first. We want to make sure that our customers are always happy and satisfied, whether it's a project that we're delivering or training or support. We want to always make sure that our customers are happy and satisfied with what we're providing. We can see from the customer support rating that we've received about a 98% excellent or good feedback from our customers, and that's from over 50,000 support cases that are logged per year. We also receive excellent feedback on our 3.5+ training courses that are delivered per year. So we always want to make sure that our customers are happy with what they receive from us. Some key facts about GreyTech. Why GreyTech? Well, GreyTech are unique in the way that they assist customers with projects. GreyTech isolates these projects into sort of 4 main categories, and they break them up. And in each of these categories or these pillars, we have specific software to tackle a specific problem. So the first category we have is GreyTech Create, where you'll create your products using GreyTech or Autodesk products, and those products can be enhanced with the GreyTech Power Packs, which I mentioned earlier. These GreyTech Power Packs are free to GreyTech customers, and if you are interested in finding out more about them, then please contact your sales representative, and they'll explain how to get the Power Pack and what the Power Packs can do for you. We have GreyTech Simulate, where you'll simulate your designs for use in the real world using market-leading GreyTech technologies and Autodesk technologies. From there, we'll take the products into a finished fabricated product and site delivery through GreyTech Fabricate. And with all of that data that you have generated in the previous steps, you need a good management solution, and that's where GreyTech Manage comes in. So this is our GreyTech Content Center. Basically, this is where we store all of our webinars, tips and tricks and tutorials and things, so including this webinar, which is currently being recorded. We constantly add webinars to our site, and it's not just in the manufacturing sector, but we also have AEC webinars as well as advanced steel webinars. So if you are looking for additional webinars, go and check out the link. Again, you can find the link in the handout. It's on the GreyTech website. It's up there at the top, and they're all free to view. You can go on at any time and just view any webinars that you're interested in. So if you have missed any webinars in the past, go and check it out. There's some really good information in there, and we are constantly adding to those. All right. So today we're going to have a look at 3D sketching in Inventor. So the things that I'd like to cover today will be creating 3D sketch geometry in Inventor, using some of the 3D projection tools that are included, creating 3D sketch constraints. So we'll be looking at some of the sketch constraints in the 3D environment. And we'll also look at actually importing points, 3D points from Excel data. And then we'll just have a look at where you might want to use the 3D sketches and where it might be better to rather use 2D sketches, because it's really easy to want to just do everything in 3D, but you'll find that sometimes it's actually easier to combine 2D sketches with 3D sketches for flexibility and sort of a more rigid model. Okay, so there's a little example that I put in that you can create using some 3D sketches and the frame generator. All right, so we're going to jump straight into it. So I'm just going to start off with a new part. And what I want to do now is I want to create a lofted component. So I'm just going to create some sketches. So I'm just going to create a few work planes. Okay, so what I'm doing here is I'm just creating some sketches that I'd want to work with to create a lofted profile. So nothing special about this at the moment, but we'll see how we can use the 3D sketches to define this shape a lot better. Okay, so I have a few profiles here. I'm going to loft them together. And you can see if I loft the shape and I just click OK, that gives me a pretty decent shape. But you can see I had no real control over the actual shape of that during the lofting process. Sure, I could go into conditions and I could try and use the directional conditions and I could try and manipulate the start and end condition a little bit, but I don't really have any real control over the shape of this. So the way that we can take control over that is by including some rails into this. So we can include some rails that will allow us to manipulate the shape slightly. But because these profiles are all sort of at different heights and different widths, we can't just go and create a 2D sketch. So this is where our 3D sketch could come in handy. So to start our 3D sketch, we will find it at the top there, just under the Start 2D sketch. And in this case, I want to use a spline to connect those. So we have two different splines that we can use, but because I'm connecting all the points together, I'm going to use the interpolation spline type, which allows me to place a spline on points. And I can just connect all these points together. And because it's a 3D sketch, it doesn't care where the sketch plane is and which direction it's going in. You just basically have to connect the points. And then remember to accept the spline. And I can do that on the opposite side as well. And I can even do the bottom just to make sure that I'm keeping that constrained correctly. Okay. So the shape looks similar to what it was earlier, but because we're working with the spline, we now have control over the shape of the spline. So we can go and insert points onto this, or we can activate existing handles. So if I had to activate an existing handle, you'll see the handle appears here, and that will allow me to manipulate this to a certain degree. But if I want to take that one step further, I can actually go and include additional points on this by inserting some points. And I can go and include as many additional points as I'd like. And I can now go and fully manipulate that shape. So I can now add more precise refinement to this. And I can do the same further down. If I want to add a point over here, I can come in and add a point. And I can adjust that shape. But I don't only have the ability to adjust it in a two-dimensional area, I can actually come to a completely different view, and I can adjust it in here as well. So if I want to pull that out more, I can come and pull that out. If I want to bring that in, I can bring that in. Now the easy way, or the easier way to manipulate these points will actually be to use your view cube and set yourself in the correct view that you'd like to manipulate these points, because remember, these points can move in all three directions at the same time, X, Y, and Z. So the way that you limit their movement to two planes, or to two angles, or two directions I should say, is to use the view cube and set a specific view. So now that I'm in the side view, I'm only going to be controlling the side and the horizontal and vertical movement of these points. So I can move them slightly more precisely. Okay, so there you can see I can manipulate those. And of course, I'm only manipulating the one side, I'm not manipulating that side. But if I do want this part to be symmetrical, I can delete that spline on the opposite side, and I can actually use the mirror command inside of, or the mirror tool inside of the 3D environment. The mirror is over there. And what I can do is just select the geometry that I want to mirror, and then I can go and choose a mirror plane. In this case, I've drawn this all symmetrically, so I can just use the YZ work plane. And there we are. I can put that in. Oh, let me apply it first. There we are. Okay, now the great thing about using that mirror command is that if I have to manipulate this one side, the opposite side moves as well. So I can keep this entire part symmetrical after I've used the mirror command. All right, so let's have a look. We'll finish that sketch off, and let's see how we can now use these 3D sketches to actually define the shape. So going back into my loft command, I'll loft the exact same way that I did before. And you can see that original shape there. But I can now go in and add the rails. So I can click over in this section here to add rails. And I can add in these rails at the top and the rails on the bottom. And now I have a more defined shape. Okay, so you can see how the 3D sketches are allowing us to actually add more precision and more control to the shape of that part. So that's one of the good uses of the 3D sketches, is adding in rails to control the shape. What we can also do is, if we need to now add in some sketches onto this curved face over here, we can't go and add in a 2D sketch, because a 2D sketch only allows us to draw in on a 2D face or a 2D surface. And we can't just go and start a 3D sketch because it'll be very difficult for us to define exactly where we want to sketch these things. So what we could possibly do is we could create a work plane. Let's say we create a work plane. We could create a 2D sketch on that work plane. And let's say that we want to sketch in a rectangle over here. And we'll make it, say, 5 by 20. Let me just align that. Okay, and I want it more or less there. So I've now drawn that 2D sketch in. And what I can do is I can actually use one of the 3D tools. So start a 3D sketch. And I can use one of the 3D projection tools to actually get that 2D sketch to lay itself along this curved face. So it will actually map it onto that curved face. To do that, we can use the project to surface tool. So we've got some projection tools here. We can use project to surface. It will ask me to select a face that I want to project to. So I'll just select this top face over here. And it will ask me to select the curves. So I'll go to the curves and I'll click on the curves that I want to project. We then have 3 different methods for projecting to the surface, and you'll just need to use the one that more closely represents the way that you want to match it. In this case, I'm just going to use the project along a vector. And with that, I'll choose a direction that I want to project, and that will be perpendicular to this work plane. And I can click OK. And that will now map that sketch onto that face. Okay, so it's not a straight sketch that's on there, it's now a curved sketch that matches the contours of that face. All right, now of course you can't go and extrude that because it's not really a flat profile. Extrude only really wants to work on a flat profile. But what we can do is we can combine it with some of the surface tools that we have up at the top here, and I'm just going to switch off these work planes. So we could combine it with something like the patch tool in our surface panel here. Patch, and I can add a patch over there. And then if we want to extrude that patch, we can use the thicken or offset tool over here. Select that patch, and we can cut that patch in by, let's say, 5 millimeters. So a little bit of a long-winded process, but we now have a cut that is cutting into that curved face. Okay. That's not the only projection tool that we have. So let's say that we wanted to create some cutouts on the side here, for instance. Again, this is also a curved face. You can see nothing is straight on that face. It's all curved and going at different angles. So what we could do is we could start a sketch on, say, a side face somewhere. Let's just project that out, get a work plane over there. And again, I can start a 2D sketch on that work plane. And let's say that I wanted to create some sort of a spline shape over here. And I'll go and just create, say, a spline over here. Just do something like that. And I'll just take that to there and maybe take this one over here. Okay, so let's just say that's the sort of shape that we want to put onto that face over there. Now, how do I get that to go onto that face? So I could go and use that projection tool that I used before, where I just basically map it onto that face. But we do have another way of doing it. We have a tool called project the intersection of 2 objects. So where 2 objects actually intersect each other. And it doesn't only work with what I'm going to create here, which is a surface, but it could work with 2 parts that intersect with each other, or 2 bodies that intersect with each other. So What I'm going to do here is I'm just going to extrude this as a surface. So I'm just going to create a surface out of that curve. And let's just give it a size that intersects over there. So there I have a surface that's intersecting. I'll just turn this off. And the way that I can project that imaginary curve that's over there, you see that imaginary curve where the two meet? I can do that by starting a 3D sketch and using the intersection curve option over here. So I'll select intersection curve, and I can choose this face over here, and I can choose the surface over here. And it could also be a work plane. So if you had a work plane running through there, a work plane would also work. And as I said, a solid would also work. So take those two, finish that off, turn the surface off so you can see. And there we have that curve nicely projected onto that face. Okay, so another really useful tool. And again, this also works really well in sort of an assembly environment, or even in the part environment where you might have two bodies that are intersecting each other. Now, how do we use that? Well, we can go and use that, combine it with some work planes. So I can create a work plane on that curve. I'm just going to create a work plane that's perpendicular to that curve. And we can go and draw a shape in on there. Let's say we draw it in a circle. Oh, let me project it out first. Project the point. Draw in a circle. Let's say we do a 2mm circle. And I can then go and sweep that along that curve. And I'll just make sure I'm cutting. Now, when we're working with complex surfaces like this, it doesn't always work out that well to just use the follow path option, because the follow path option is only really looking at the path itself. But in this case, it might work okay because we're working with a circle. But if you're working with something like a rectangle or some specific shape, it might not actually cut correctly. So what we tend to do is we use the follow path, or the guide option over here. Sorry, the guide option. And we can actually select the surface over here, that face, as a guide. And that helps Inventor to actually match the angle and orientation of that profile to the surface as well as to the curve that we are sweeping along. Okay, so if you ever find that you want to do this and it doesn't actually sweep properly, try using the guide option and select the face as a guide surface. We can click OK. And that will now cut it out. So I could have extended the curve a little bit further. So you can always go in and just adjust that so it cuts correctly. Okay. So there we are. Those are some of the really good uses of the 3D sketch. Okay, now you do have another option as well. If you do want to just draw directly on a curved face, again, you can do this from the 3D sketch. We have this curve on face. So if you do want to draw something on the face directly without having to project it on, you do have the curve on face. And you can use it as you want, depending on how well you think it works, but you can see here that we can go and draw a spline directly on there. Okay, so that will match it up. It's not the easiest way to sketch, but if you are trying to just create a spline, you'll see that that actually draws a spline across the face. And if I just drag this down so you can see, if I drag it down, you'll see it actually matches it along the curve. Okay, so those are a few of the tools that you have at your disposal there. Now let's go and have a look at another example. So I'm just going to start off with another part. Now, if you tend to use the frame generator, you know that you need to generate some skeleton lines so that you can actually create frames on those skeleton lines. And what some people might want to do is to draw everything in 3D. So they start off with a 3D sketch and they just go and draw everything in 3D, which might be okay. But from my own personal experience, I found it very difficult to go back and manipulate that sketch later on when it's purely 3D. So I'll show you how you can draw it directly in 3D. When we use a 3D sketch, we have the 3D line tool, and if you right click, you have some options that might be interesting or of interest to you. We have the auto bend option, which will add a little bend between any of your lines that you draw in. So where two lines meet, it will add in a little bend or a little fillet. But I'm going to turn that off because I want all my lines to be straight. And we have an ortho mode, which will try and keep the line at 90-degree intervals. Okay, so it will prevent you from drawing strange angles. Sometimes it's really useful, like on a frame generator where you might want straight lines. But I'll show you how we can do it without the ortho mode. So the way we do it is we can just start off like that with the line, and we can draw it the way we normally would. But what I want you to be aware of is that you don't want to be sketching in a 3D view like this necessarily, because you might end up drawing in the X, Y, and Z directions all at the same time. Okay, we can limit that by clicking on one of these work planes first, and that will limit the work plane that we're drawing on. But you still just need to be careful, because you might start drawing something and then when you rotate the model, you realize actually you've been drawing in the X, Y, and Z direction all at the same time. Okay. So to prevent that, you can use the view cube once again to specify where you actually want to draw. If you're drawing in the XY or the XZ or the YZ work planes, simply by selecting the correct view. And we can just go and draw in the sizes that we want. Let's say we want to make this 500. Come across by 500. And then let's say I go down and connect that. So some of the constraints that we have that are similar to our 2D environment would be something like the equals constraint. So I can say that this and this should be equal, and I make this and this equal. Okay, so that's fine. And if we go and manipulate those, they change okay. Now, some of the other constraints that we have, I'll show you. If we go and create a line, and it looks like we're drawing this line straight, because you can see it's very difficult to tell. And again, I haven't selected a work plane and I haven't aligned my view cube correctly. So I'm just drawing sort of freehand here. And I'm just trying to basically get the shape that I want. And it might sort of look okay, but if I actually rotate the view, you can see that I am completely out. I've drawn in the X, Y, and Z directions all at the same time. Okay, so if this does happen to you and you want to try and actually limit the directions of these lines, you can use some of these additional constraint tools that they've provided for you. So we have these ones here in particular, which will align your sketch with the XY, the XZ, or the YZ work planes. And in this case, I can look at which work plane I want it to be parallel with, and I want it to be parallel with the XZ work plane, right? So I can find the XZ work plane option here, click on it, and click on the line, and that line will now be parallel with the XZ work plane. I can do it for that line there. Oh, that's pulled it too much. Let me just manipulate this a little bit here. There we are. And then this one should already be aligned, so I can't create the constraint. So now if I look from the side view, that's all parallel with the XZ work plane. Okay. But that doesn't help me here with the angles of these. And it's very difficult to add in any angles. In fact, you won't even be able to add in the angle constraints here. Oh no, it will allow you. Sometimes it won't allow you to add in an angle. And it makes it really difficult to actually constrain the 3D geometry. But we do have another set of constraints that will allow us to get these aligned with some of our predefined orientations, the X, Y, and Z directions. So for instance, if I want these lines to be parallel parallel with the Z direction over there, so I want them to be parallel with the Z direction, I can then go to the Z parallel option here, and I can make it parallel with the Z axis. And that's going to pull that line straight. And the same for that one there. I can make it parallel with the Z. And for this line here, I can make it parallel with the X. So make it parallel with the X axis, and that will pull that in place. Okay, so you can manipulate the 3D sketches, but I'm going to show you how we can rather create this using 2D sketches and then fill in the additional geometry using 3D. The reason why this is better, in my opinion, is because it's a lot easier and a lot quicker to define some 2D profiles, and it gives you a good anchoring point for your 3D geometry to link to. Because again, you'll see that we don't have any indication if this geometry is fully constrained or not, and in this case it's not. Whereas in the 2D environment, it easily tells us if we still need more constraints or more dimensions, and we can see where those constraints and dimensions are that are needed. Whereas here, it's just kind of floating around in 3D space. And in fact, if I pull this, you can see it's not grounded to anything, and it would be really difficult to work with and manipulate at a later stage. Okay, so how can we do this using 2D instead? So let's just go start a new part. And the way that we can do this is by using some work planes. So I'll use the XY work plane, and I'll just offset another work plane. Let's go negative 2000. And I'll create a 2D sketch on the one. And I'm going to create a rectangle here, and let's make it 500 by 500. And I can go and create another sketch on that work plane over there. And I'm just going to project out this geometry, so I don't have to redraw that rectangle in. Of course, if you want different sizes on the opposite face, you would need to add in the actual sketches yourself. All right, so now that I have those two sketches there, I could go and add in maybe a work plane in between the two if I needed one. So I could add in a work plane that's mid-plane between those two planes. Where is my offset plane? There we are. And again, I could create a sketch on that if I needed to, and just project that geometry out there. And because those are projected, if I change these sizes, they'll all adjust. Now I can go and sort of supplement this or complement it with a 3D sketch if I need to. So a lot easier now. I don't have to worry about sizes. I can just simply go and connect the 3D line to the points that I want to connect. And then any additional lines that I want to add in, let's say I want to add in a cross piece over there. I could even add in a line to there, and then another line to there. Okay, so you can see that we can go and add in these 3D lines really easily. And we don't have to worry about creating new work planes and creating new 2D sketches each time. Okay, now there I've made a mistake. As you can see, I didn't link it up to the line, so it's actually drawn it in 3D. But that's no problem. Again, we have the coincident constraint that you should be familiar with, and that works the same in 3D. We can take that point and connect it to the point that we want. And it's the same here. I think that I'll just connect this to that line. Okay, maybe it is already connected. So those might be connected already. All right. And I can double check that that all adjusts correctly. So I can go and change some of the sizes just to make sure. So that 2000, let's make it say 5000. That all looks like it updates correctly. So that's fine. I'll just take it back. And I could then save that out. And I'll just call it skeleton. And we can go and place this into an assembly. Place the skeleton in. Where have I said? There it is. Okay. Just save this as a frame. And I could go and combine it with my frame generator. Oh, let me take all of that. Just wait for that to build. Let's just turn off all of those. Okay, and there we are. So we can very easily, very quickly build those 3D sketches and then build a frame around it, as you can see there. And of course, we can always go back to that model. And because those 3D sketches have anchoring points that they can link to, that's going to keep that sketch nice and robust. And they'll all be driven from work planes and 2D sketches. So if we want to change anything in there, and let's say I want to change that sketch, make it 800. So just double check that it's all updating correctly. It should all be okay. Come back to our frame, update it. And there we are. It's all updating nicely. Okay. Now, if you wanted to do updates like that with the 3D sketch, it does get a lot more difficult if it's purely a 3D sketch. Sometimes you can manage it okay, but you'll find that because you're working with 3D lines in a 3D space, they tend to not constrain correctly and they might shift out of place. So my advice, just from previous experience, would be have some anchoring points, either from some 2D sketches or some work planes or some points that you've locked in space, and then link your 3D geometry to that, connect your 3D geometry to that. You can also do it in an assembly environment as well, where you can actually project out some of the points from the 3D assembly and then create your 3D sketches from some of those points. And I'll show you that in an example soon. Okay, so again, my word of advice is the better way to use 3D sketches, personally, I think, will be if you have some anchoring points that can be easily controlled from work planes or from 2D sketches. Okay. So let's go and have a look at something else that we can do with 3D sketches. So I'm just going to start a new part. And if you want to be able to bring in some work points, some 3D work points, we can do this through Excel. So let me just open up an Excel document that I'd created, and I'll show you what the Excel document looks like. So if you know where you want the points to be in the 3D space, you can basically type in these coordinates as X, Y, and Z coordinates. Okay. So these will be the absolute positions. You can see I'm going to start off on 0, 0, 0 in the XYZ location, and then I'm going to move forward by 100. And you basically plot where you want these points to be as their absolute position in the 3D space. And you can type in as many points as you want. You can see I've just done a few there. It looks like I've done about 8. But you can continue adding additional points in, and then just save that document somewhere. And if we want to now pull that document in, we can come into Inventor, start a 3D sketch, and to import those 3D points, we'll go to the Insert Points over here. We'll find the points that we want to bring in, the Excel document, and we'll have a look at these options, and I'll come back to these options. So for now, I'm just going to leave it on the default, bring in those coordinates, click Open, and there we are. It's that easy to bring in points in a 3D workspace. So you just type in whatever you want in the Excel document, and then import them into Inventor. Now with that, we can go and link those points together with lines. So if we want to join them up with lines, we can. Okay, as you can see there. So there I can join all of those up with lines. If I want to add in some of those bends or those fillets that I mentioned earlier, we've got the bend tool over here. Type in the radius that we want, let's say 20, and I can just put in those bends. Okay. Now that's a little bit of a long-winded process. So there is an easier way to bring those points in and have them linked up as lines automatically. And the way that we do that is by importing the points and then coming down to our options button over here. So we choose options and we can choose how we bring them in. So we can bring them in as points, which is what we did. We can bring them in as lines, or we can bring them in as a spline. Now in this case, the spline is going to be a little bit crazy. I'll just show you because the points are quite close to each other. But you can see how it links those points together with a spline. Okay. In this case, what I'm going to do is bring it in as points, but I wanted to add in the bend automatically. So to make sure it adds the bend in automatically, I'm just going to launch the line tool. I'm going to right click and then just select auto bend. So I'm just going to enable the auto bend like that, and then I can just press escape. And if I want to control the actual bend radius, I need to come into the tools tab at the top, go to my document settings, go to sketch, and then I choose the auto bend radius here, and I'll choose 20 again. Click OK. I can now go back to my 3D sketch environment, click on points, choose coordinates, have them come in as lines, click OK, open, and they'll now come in as lines with the bends added in automatically, and they're all in at 20 millimeters. Okay. So a really useful feature, especially if you know where you want lines to go. If you do have the 3D coordinates, you can then create those 3D coordinates in Excel and then just bring them into Inventor and have them come in as lines or splines. Okay, and of course you can add on to these using lines or splines or anything else that you need to add in additionally to this, but it's a good starting point. And again, we have those anchoring points that we can work with. All right. Now, this is not really linked to anything, so all of this can still move. So you just need to be careful of that. But what we can do is we can always lock these points in, so you can just fix them in, just to prevent them from moving. Or if you want to still add in some dimensions, you can. But since you brought these in as 3D points, you probably want them to stay in those positions. So I would just go and fix them in the 3D space. Okay. So there we are. And the last thing I wanted to show you is how we can actually work with these 3D sketches inside of an assembly environment, because that's really where they have a lot of strength. Being able to link certain things together inside of a 3D environment or in an assembly environment. So let's go and open up an assembly and have a look at how we can use these. So I'm just going to open this up here. Okay, so I've got two components here that I might want to link together, and Inventor does have a tube and pipe environment that would do this better for working with tubes and pipes, but you might not want to go into the tube and pipe environment, or you might want to just create something really simple that isn't actually a tube and pipe type thing. It could be, some other kind of object that you're trying to create. So let's say that we now want to actually create something in between this connector here and that connector over there. So we could go and create a new part, and let's just call this tube, for instance. And I'm just going to create this as a millimeter part, and I'll just place it on the origin point here. Okay, now how do I actually connect these two things together? Well, I can start off with a 3D sketch. And if I want to project out the geometry from both of those points, I can use the include geometry tool over here. And this lets me include geometry from anywhere on the model. So you can see these are two completely disconnected points. They aren't on the same work plane in any direction, but the include geometry allows me to pull out those points. I could then go and create a line on that. So I could just go onto that point there, and I could create a line, and let's make it say 100. And I could come to this side here, create a line, make it say 100 as well. And then from there, I could link those two together using a spline. So I could go here and I could create a spline. Let's say I want to just draw a spline in there. And then I can go and actually refine that spline. So what I'll start off by doing is actually making that spline tangent to that line over there, and then also smooth it out. So we can use the tangent constraint to make the spline tangent to that line, and we can make that spline smooth to that line, and it just makes it a little bit smoother and nicer. And we can do the same over here. We can make these two tangent to each other, and we can just make them smooth. Now that we've done that, we can use our view cube to position the view that we want to alter the points in, and we can start to refine this a little bit. So I can say, well, I want to bring that up a little bit to there, bring that up to there, maybe have that coming across like that. And again, we can add in additional points if we need to. And then I can go into a different view and make some adjustments here. Just make sure that that's not too curved. Okay, that looks nice and smooth. I can finish that off. And then again, I can make a work plane that is perpendicular to that point over there. Create a sketch on there. And what I'll do is I'll just make a circle in there. Oh, let me project it first. Create a circle. Let's make that 17. And I can then sweep along there. And in order for this sweep to work, that spline needs to at least be tangent to that line over there. If it's not tangent, the sweep won't work. It sees them as disconnected lines if the spline and that straight line are not at least tangent to each other. But again, we'd like to make it tangent and smooth, just to smooth it out. And there we are. We've now created a part using 3D geometry. We were able to project out the geometry straight from the assembly. We could then create a spline and fully define that spline the way we wanted to, and then actually sweep it out. And you can see I can open that up and I can go and detail that part as an ordinary part. Okay, so those are some of the uses for 3D tools. Now, of course, there are many more 3D tools that you can work with, but those are just a few of them. So, with the little bit of time that we have left, I'll welcome any questions that you might have. If you don't have any questions, then thank you very much for joining us. Again, this webinar is recorded, so if you want to go back and view it, give us about 2 weeks. It normally takes about up to 2 weeks for this to be loaded to the website. But if you do want to go back and have a look at this video again, or this webinar again, you'll find it on the website. Okay, if you don't have any questions, then thank you very much for joining us and have a great day further. If you do have questions, then please feel free to add them into the questions section. Thank you.